Welcome to Spring LIB.
This is the answer to Chapter 19, problem number 13 from the Smith Organic Chemistry textbook. And this problem says, given the pKa values in Appendix A, which of the following bases are strong enough to deprotonate acetic acid? And so basically, we are comparing pKa values here, and any base whose conjugate acid has a higher pKa then acetic acid's pKa can deprotonate acetic acid. So we're talking about bases, but pKa is in terms of acids. So we need to consider the conjugate acids of these bases. And then remember, the higher a pKa value, the less acidic an acid is. So the higher the pKa value, the more basic a molecule is. And so we're looking for molecules where the pKa values are higher than that of acetic acid. And so acetic acid's pKa is 4.8. So we need to think about the conjugate acids of each of these bases and then look at their pKa values and then make the comparison that way. So for A, we have fluoride ion. So the conjugate acid of the fluoride ion is going to be HF. HF is a very strong acid, and its pKa is, according to Appendix A, 3.2. So 3.2 is not higher than 4.8, and so no, the fluoride ion cannot deprotonate acetic acid. For B, we have tert butoxide. So its conjugate acid is going to be tert butanol. So T-butanol, pKa of T-butanol is 18. And so, yes, this is strong enough. 18 is greater than 4.8. So, yeah, strong enough. Let me move this up a little bit. Okay. So we have this deprotonated methyl group here for C. The conjugate base, the conjugate acid of that is just going to be methane. And the pKa of methane is 50, which is quite large. And so, yes, that's strong enough to deprotonate acetic acid. Okay. And then so for D, the conjugate acid is going to be ammonia. Ammonia's pKa is 38. So yes, strong enough. And for E, we have chloride ion. The conjugate acid of chloride ion is going to be hydrochloric acid. So hydrochloric acid is a very strong acid. So we should probably know without even looking this up. But according to Appendix A, the pKa of hydrochloric acid is -7. And so obviously -7 is less than 4.8. And so the answer for E is no. Okay. And so again, the way to solve this problem is to use Appendix A, find acetic acid's pKa value, which is 4.8, and then consider the conjugate acids of all of the bases listed here. And those conjugate acids that have a pKa value greater than that of acetic acid are strong enough to deprotonate acetic acid. And that's the answer to Chapter 19, problem number 13.